In this instructional video, I'm going to label it as 15.1, title, General Rule of Addition for Probability of Two Events. And I will start out with an example. In a dog park, there are 8 terriers and 12 Labradors. Let the event T denotes that the dog being selected is a terrier, and let the event L denote that the dog selected is a Labrador. And so there are a total of 20 dogs, 8 terriers, and 12 Labradors. And very simply, the probability of selecting a terrier is 8 out of 20, and that gives you 0.4. Probability of a Labrador is 12 out of 20, is 0.6. That's straightforward enough, but now let's ask something that's a little bit more involved. What's the probability of selecting a terrier or a Labrador? Also, what's the probability of selecting a terrier and a Labrador, meaning a dog that is both a terrier and a Labrador? Now, this case is easy. A dog is either a terrier or a Labrador. It can be both. So this case of a dog being both terrier and a Labrador has to be 0. We know that. And so let's move on to the case of probability of a dog is either terrier or a Labrador. Of course, logically, you know it has to be 1 because that's all you have. The dog part only has Labrador or a terrier or terriers. And so, but let's use the general rule to see how it works out. So P of T or L is equal to P of T plus P of L minus P of T and L. Remember, or is right here and is right here, okay? So probability of T is 0.4, probability of L is 0.6, and probability of T and L is 0, and therefore that's equal to 1, as you expected. Right now, let's move on to a second variation of the same example and ask different questions. There are only 17 owners because some owns one of each breed. Then what's the probability of being each kind of owner, right? So right now, the question is about the owners, not about the dogs. Before, the Venn diagram is a simple one. You ask a question, what breed is selected? Then all you have to do, just draw the 2 disjoint sets of terrier and Labrador, and you know that they are complement of each other, meaning that the probability of T plus probability of L is equal to 1 because there are only 2 possibilities here. So these both probabilities has to add up to 1. But right now, the Venn diagram for the owners will be different, and this is how you have to draw it, okay? So case 1, you have the owner owns a terrier, and case 2 is owning a Labrador, and in case 3 is owning one of each, owning both. And I've worked it out, this to be 5 for case 1, 9 for case 2, and 3 for case 3. You can check that easily. Okay, so this is how you draw a Venn diagram for the owners. So T, right here, those who owns terrier and nothing else is 5. Those who owns both is 3. And those who owns a Labrador and nothing else is just 9. Okay? So the probability of owning a terrier, okay, is 8 out of 17. Because you're looking at this part right here. Because even though you could be owning both, the question is simply owning the terrier. Okay, so it's really 8 out of 17. What about a probability of owning a Labrador? Then you have to look at the owner in either cases owning Labrador only or Labrador plus terrier, but it doesn't matter because the question only worries about the Labrador, so it's really the 12 over 17. Now, if you look at the cross part, the overlapping part, there are owners who owns both terrier and Labrador, and that's 3 out of 17, right? And so that's easy enough. We just read out the Venn diagram. But now we can ask some question and say, what is the probability of owning a T or L? Of course, you know, just by logic, it has to be 1. But we're going to do this demonstrating the general rule of addition, right? So P of T or L is equal to P of T. Remember, now we're talking about ownership, not the dog themselves. plus P of owning a Labrador minus the probability of owning a T and owning an L. Okay? And so in this case, probability of owning a terrier you already have is 8 out of 17, plus owning a Labrador is 12 out of 17. And probability of owning both is 3 out of 17. Okay? So let's look at this. Combining these two, the individual probability is 20 out of 17 minus 3 out of 17. And that's indeed 17 out of 17, and that's equal to 1. Okay, so what's going on here? You see, look at these two probability right here. The probability of owning a terrier is this part right here, and that's 8 out of 17. The probability of owning a Labrador is this part right here, and that's 12. But when you do this, what happens? You overcount this part twice. And so what you have to do is you have to take one part of that out, right? So this part right here, 8 out of 17, includes this part. So is P of L. It also includes this part. So you have a double counting, and that's why you have to subtract away 3 out of 17. And that, of course, gives you all the proper counts, and that gives you back to 1. So the probability of owning a terrier or Labrador is, once again, 1. Demonstrating this rule actually works. So the addition rule really there are only two equations that you have to work with. One is literally event A or B is equal to PA plus P of B minus P of A and B. Okay? But another case that you have to think about, another equation you have to think about, is the complementarity rule. In other words, P of A equals 1 minus P of AC. Or in this case, since you're talking about B as well. These are the rules that always work. Okay? And so you could look at A and the complements of A, or B or complement of C. In the previous example, when we talk about all these dogs, we could ask questions such as, what's the probability of owning a terrier but not Labrador? Now that question could be a little bit confusing because, you know, T and L is easy, but T and L is not so easy. So what you have to do is you have to look at L and then its complement, not L, and work out how this relates to that and use this equation to figure out what's the answer for this.